In the second part of lesson 13.8, we're going to be looking at graphing reciprocal trigonometric functions. So first function we have is y equals sine x, which is our regular function, and then from that we're going to graph its reciprocal, y equals cosecant of x. And we're going to be graphing in the interval from 0 to 2 pi. So set up my coordinate plane, and I'll mark in here a scale up to 2 pi. Okay, so then if we're going to graph the sine function, we know that the sine of 0 is 0, and let's say this is 1 and 2, negative 1, negative 2. So then the sine of pi halves we know is at the amplitude, so that would be at 1 because the a value here is 1. And then the sine of pi is back to equilibrium. And the sine of 3 pi halves is at a minimum amplitude. And then the sine of 2 pi is back to equilibrium. So here's our sine curve, like so. So from this, we're going to graph the reciprocal function y equals cosecant of x. So if the sine of 0 equals 0, the reciprocal to 0 would be the cosecant of 0, which is undefined. So where we have the 0 for sine, we're going to have a asymptote. So all of the zeros turn out to be asymptotes, like so. So then we have the sine of pi halves, which we know is 1, and the reciprocal to 1 is also 1. So at the cosecant of pi halves, we're at 1. So at the point here where the sine was 1/2, the reciprocal of 1/2 would be 2. Same thing over here, so that would be 2. So the graph ends up looking like this, going towards the asymptotes. And then the sine of 3 pi halves is going to equal negative 1. So the cosecant of 3 pi halves will be the reciprocal of negative 1, which is still negative 1, right here. So in this region, the curve goes downward. So that's the graph of the sine of x and also the cosecant of x in the interval from 0 to 2 pi. So if we were to take out the blue line, what we would have left is the cosecant of x. Okay, so let's look at another example. In this one, we would use our graphing calculator to graph y equals the secant of x, which we will do in class. But right now, what I want to show you is what the secant of x looks like. So if we start with the coordinate plane, and we'll label it the same as we did before. The reciprocal to the secant is going to be the cosine of x. So if we were to graph the cosine of x, we know that the cosine of x would start at the amplitude. Well, I guess it's not that high. Would start at the amplitude. It would go down to equilibrium, down to a minimum amplitude, equilibrium, and back to maximum. So this is what the cosine looks like. So again, the secant is the reciprocal to the cosine. So anywhere where the cosine equals 0, the secant is going to be an asymptote. So we have asymptotes in here. And similar to the cosecant, the secant ends up having these curves that go towards the asymptotes. And so at the y-axis, we have a curve going like this, and of course there's an asymptote over here at negative pi halves. And we have a curve like this with an asymptote over here at 5 pi halves. So the cosecant then, or the secant is the green stuff, so I'll take the blue out of the way. So if we're looking for the secant of 20 degrees, we would need to change our radian measures here into degree measures. So we know pi halves is 90 degrees, and pi is 180 degrees. So if we're looking for 20 degrees, that's going to be right about here. So if we take that up to the curve, the value to the secant of 20 degrees is going to be a little bit more than 1, maybe 1.1. So in class, we'll calculate that on our calculator. Finally, we have a story problem here. It says a restaurant is near the top of a tower. So here's the tower. Restaurant might be here. A diner looks down at an object along a line of sight that makes an angle of theta with the tower. So the person in the restaurant is looking outside down like this, where theta would be there. The distance in feet of the object, which is here, from the observer, which is here, can be modeled by the function d equals 601 secant theta. So d is going to be this distance across here. So to calculate this, you would simply put the 40 degrees in for theta. And so then, since your calculator doesn't have a secant function, what you would calculate is 601 times 1 divided by the reciprocal to the secant is the cosine. So you'd put it in like this, and it will calculate the distance. And that's it for 13.8.